Okay, let's take a look at the sample problem. This is sample problem 3.4. It says that butyric acid, which is also known as butanoic acid, has the chemical formula C4H8O2, is one of many compounds found in milk fat. First isolated from rancid butter. You know, rancid butter is butter that's gone bad, right? In 1869, that's right after the American Civil War, butyric acid has received a great deal of attention in recent years as a potential anti-cancer agent. Assuming that the only products are carbon dioxide, CO2, and water, H2O, write and balance the equation for the metabolism of butyric acid. Now remember, metabolism in terms of chemical balancing is the same as combustion. So combustion, metabolism is the organic compound, and recall that organic compounds are compounds that have carbon and hydrogen in them, hydrocarbons, reacting with oxygen gas. And oxygen is the oxygen in the air that we breathe. And remember, it's O2, not O. It's diatomic, it's O2, to form carbon dioxide and water. Very, very simple. So let's write the equation first. So the reaction is between butanoic acid, C4H8O2, and its metabolism, so plus O2. They are going to react to form carbon dioxide and water. Okay, there's our equation. Now it's not balanced, but it is written. So let's go ahead and do the balancing. The general theme for combustion balancing is do carbon first, then hydrogen, then oxygen. That would be the order that you want to do, okay? It's not the only way to do it, but it's what I would recommend. So let's begin. We have more carbons on the left side than we have on the right side. Remember, if there's no number written in front of a reactant or product, that means there's one. So that means there's one carbon dioxide, which means there's one carbon. So we want to have more than one, right? If we have 4 on the left, we want to have 4 on the right. So what we do is we put a 4 in front of the carbon dioxide. So now there's 4 carbons on the right, just like there is on the left. Let's go on to the second element. The second element is hydrogen. How many hydrogens are there on the left? Remember, if nothing's written here, it's just a 1. So that means there's 1 of the butyric acids. So there's 4 carbons, because 4 times 1 is 4. There's 8 hydrogens, because 8 times 1 is 8. And there's 2 oxygens, because 2 times 1 is 2. So there's 2 oxygens in butyric acid, and there's 8 hydrogens. How many hydrogens are in a water? There's 2. So you ask yourself, what do we have to put in front of the water so that you get 8? We need 8. So something times 2 is equal to 8. Well, that's 4, right? 4 times 2 is 8. So now we have 8 hydrogens on both sides of the equation, and we have 4 carbons on both sides. So now it's just the oxygen that we have to do. So I'm going to write the equation again, because it's a little busy up there. We now are going to do the third element. So I'm going to write O2 and put a little line in front of the O2. 4 CO2 plus 4 H2O. Okay? So now we need to figure out how many oxygens. Well, on the left side we have 2 oxygens, and then we have another 2. On the right side, we have 4 times 2 is 8, and then 4 times 1 is 4. So it looks like on the right side we have 12. So that means we want to have 12 on the left side, right, the reactant side. We need to have a total of 12 here. Well, there's 2 here already. If we were going to change the number here, that'd be a problem, because if we change the number here, that would change carbon, hydrogen, and oxygen. That would complicate things. So let's not change this number in front of the butyric acid. Let's just change the one in front of O2. Because if you change the number in front of O2, that doesn't change anything. Okay? So We have 12 on the right side. We've got 2 here. So that means we need 10 here in front of the 10 for the oxygen in the O2, right? Why 10? Because you got 2 here and you need 12. So 12 minus 2 is 10. So that means we need 10 here. What times 2 is equal to 10? 5 times 2 is equal to 10. So let's try that. Let's put a 5. So let's check it. 5 times 2 is 10, plus another 2 is 12. 4 times 2 is 8. 4 times 1 is 4. 8 plus 4 is 12. We got 12 on both sides. 4 carbons on both sides and 8 hydrogens on both sides. So there you go. We're done. That's a balanced equation. Each element is balanced. Remember, we change the numbers in front of the reactants and products. Those are called coefficients. That's a mathematical term. You've seen that in math classes, coefficients. And then we have the other term, which are called subscripts. It says in the reading we don't change the subscripts, because if you change the subscripts, that changes the chemical nature of the substance. For example, O2 is called molecular oxygen. That's what we need to breathe, and that's what plants produce due to their processes, photosynthesis. O3, if you change the subscript, that changes it to O3. That's called ozone, and this is a poison. So the reason that we don't change the numbers that are subscripts is because the subscripts change the chemical material that you're dealing with, and we don't really have full control over that. We can't balance it by saying, oh, we'll just turn it into ozone, because we don't have the ability to change the oxygen that's in the air into ozone to run this reaction. Okay? So there you go. There's a nice practice problem, a sample problem 3.4. Of course, try the A and B and the checkpoints for this type of problem.